So for this video, we're going to be working on drawing the Lewis structure of an atom. So the main idea of chemical bonding is that atoms combine in order to achieve a more stable electron configuration. That is to say that an atom is the most stable when it has the same number of valence electrons as a noble gas. So valence electrons are the electrons in the outermost shell of an atom. So noble gases have 8 valence electrons in their outer shell, and helium, which is also a noble gas, has 2. So atoms bond to achieve this configuration, 8 valence shell electrons. So when atoms bond, only their outer regions make contact. Therefore, we will be concerned primarily with the outer electrons when it comes to chemical bonding. The inner electrons we will not deal with. So let's draw the Lewis structure for some elements. So let's take carbon, for example. So first we draw the symbol for that element. In this case, the symbol for the element carbon is C. Then we draw an imaginary box around the symbol. So let's go ahead and draw that imaginary box. So then we take the group number for that element. In this case, it will be 4 because the group number of carbon is 4. And then we use this group number to determine the number of valence electrons for that element. So since the group number of carbon is 4, carbon will therefore have 4 valence electrons in its outermost shell. So 4 valence electrons. So finally, now that we know the number of valence electrons that carbon has, we place those electrons around the imaginary box that we drew around the symbol for carbon. One electron at a time and one side at a time. So 1 electron here, 1 electron here, 1 electron here, and then 1 electron here. So it doesn't matter which side you start with or the order with which you place the electrons, as long as you fill each side of the box with the 1 electron before moving on to the next side. So let's try oxygen next. So next we have oxygen. So let's draw the symbol for oxygen. O. So for oxygen, oxygen is going to be in group 6, right? So if you look at a periodic table of the elements, you will see that oxygen resides in group 6. So we know that oxygen is going to have 6 valence electrons. So 6 electrons in its outermost shell. So let's draw our imaginary box. Normally you wouldn't draw this box when drawing the Lewis structure or the Lewis dot structure for atoms, but in this case we're just using this imaginary box to give us a framework for placing the electrons around the atom. It just makes it easier. So, since we know that oxygen resides in group 6, we simply draw our electrons around oxygen, one electron at a time, one side at a time, and then we use dots to represent our electrons. So let's draw one dot here, one dot here, one dot here, and then one dot here. So now we have 4 electrons around oxygen. But we know that oxygen has 6 valence electrons, so we just go back around the square, filling each side with 1 electron until we get to 6. Now it doesn't really matter where you place these dots, as long as you go one side at a time and 1 electron at a time. We very may well have placed the 6 dot or the 6 electron right here, or we could have placed the 6 electron right here, right? It doesn't really matter where you place the electrons, as long as or I guess I should say, it doesn't really matter which order you place the electrons, as long as you go 1 dot at a time and 1 side at a time. So, and finally, let's go ahead and try drawing the Lewis dot structure for the element neon. So neon has the symbol Ne, right? So, and neon exists in group 8 of the periodic table. So since we know that neon is in group 8, we know that neon will have 8 valence electrons. So 8 valence electrons. So because we know that neon has 8 valence electrons, each side of this box will have 2 dots around it. So each side of this box will have 2 dots around it, with a total of 8 electrons in all. So since neon has 8 electrons in its valence shell, it's stable and it tends not to react. And elements with this property we call noble gases. So noble gases. So these are elements that tend not to react with other elements very easily. And if you remember, atoms tend to bond in order to gain stability, right? So therefore, neon, which is a noble gas, has no need to react since it's already stable, right? Since neon is already stable because it has these 8 electrons in its valence shell, there's really no need for neon to react with another element. So here's a question. Why might an element like oxygen exhibit similar bonding properties to an element like, say, sulfur? Right, I'll give you a minute to pause to think about the answer to that question. So let's go ahead and draw the electron configuration of sulfur, or the Lewis dot structure for sulfur. So sulfur, we know that it has the symbol S, and if we draw our imaginary box around it, and we fill up our box with electrons. Since we know that sulfur also resides in group 6, it will have 6 valence electrons. And since it has 6 valence electrons, we are going to fill up this box with 6 electrons. So 1 dot, 2 electron, 3 electron, 4 electron, 5 electron, and then let's draw a 6 electron right here. Right, so this is going to be the Lewis dot structure for sulfur. So if we compare the Lewis dot structures of oxygen and sulfur, we can see that they have the same valence electron configuration, because they exist in the same group, right? They're in the same column of the periodic table. Now, that's not to say that they have the same number of electrons. That's only to say that they have the same number of electrons in their outermost shell, right? The same number of valence electrons, right? So when we're drawing Lewis dot structures, we're only concerned with the electrons in the outermost shell. So, and if you remember, right, when atoms interact to form chemical bonds, only their outer regions are in contact with each other, right? So therefore, to achieve an octet, right, an octet is when there are 8 electrons in the outermost shell, right? When there are 8 electrons, 8 valence electrons, or we can say when it achieves a noble gas configuration, we might expect oxygen and sulfur to form the same number of bonds. In other words, 2 bonds in order to complete their octet. And therefore, we can say that sulfur and oxygen exhibit similar bonding properties, right? Because they usually tend to form 2 bonds. With that being said, thank you for watching and have a nice day.